This last section in chapter 19 talks about blood typing and some other blood tests, things like hematocrit, which we can do in lab. And then it also talks about a lot of like the lab values and blood tests you'd get at the hospital. So check that part out. Don't spend a ton of time, but kind of file that away. Those are the sorts of things that you'll start seeing in pathophysiology class and things like that. But I did want to cover blood typing in a little more detail, just because this is a topic that a lot of students find confusing. So the basic premise of this is that your blood type is determined by the proteins on the surface of your red blood cell. And this is inherited, right? So you have a gene to produce certain proteins and put them on the outside of your cell. Now, those proteins, antigen is just another term for protein. It's technically a protein that stimulates an immune response. But basically, if you have type A blood, grab my pointer, if you have type A blood, right, that means that you have the A antigen, okay? And so I usually actually go through here and just draw these as A's. Well, what does a little circle mean? Put an A on there, right? So you have this protein, the A antigen, on the surface of your cell. Now, since you make that protein, you would never produce an antibody like this one that would attack that antigen, okay? Instead, what you produce is an antibody that would go after antigen B, right? Your body has never seen that before. It's foreign. It might as well be E. coli, right? So we would attack it. And so someone with type A blood produces the anti-B antibody, or immunoglobulin, if you want to say it that way. Okay, right? So then if you are type B, you have the type B antigen, right? And I would actually just draw this with like little B's on the surface, but whatever. This textbook publisher paid an artist better than myself. So you have this B antigen, this specific protein on the surface of your red blood cells. You would not produce the antibody that would attack it, but instead you produce antibodies that would go after A, because that's foreign to you. Now, if you're type AB, you have both A's and B's on the surface of your red blood cell, and you don't want to attack either of them. So you don't make the anti-B antibody or the anti-A antibody, right? So neither of those antibodies. If you're type O, you have these naked red blood cells, right? We don't have that A or B hanging out on the surface. And so either of those would be seen as foreign. And so sure enough, we produce antibodies against both. Now, what often helps people kind of think through this is to think about what kind of transfusion someone could get, right? So say you have type A blood. Maybe we'll just add a little box up here, right? What kind of transfusion can someone with type A blood have? Well, you could give them A, right? That's what they already have, so that makes a lot of sense. But basically, if you give them anything with a B, they will attack it. So you can't give them type B blood, nor can you give them AB blood. Now, think about why you could give them O blood. These red blood cells are naked, right? There is nothing for this anti-B antibody, to attack, right? And that's really the problem, is if you have a transfusion reaction, what it means is that antibodies that the recipient has are actually attacking the blood that you gave them, and you are going to have this massive hemolysis, right? Red blood cells getting split open, clotting taking place. So like you only give someone blood if they're already kind of in a bad way, and now you've made things worse. Like you can kill people this way. Okay, how about type B? What should they be able to have? Okay, so definitely B. They're not going to attack that. And O, good. Really, you can give them anything except something that has an A. So that cancels out type A and also AB. Well, how about someone with type AB blood? They don't make antibodies against A or B. So you could give them AB. That makes sense. That's their own blood type. Could you give them A? Are they going to attack A? Yeah, so that's perfect. We can give them A. Can we give them B? No antibodies against B, so that'll work. And good old naked O, right? We're not going to attack that one either. So someone with type AB blood is referred to as the universal recipient, right? Because they can get any of those 4 blood types. Okay. Now type O, since they're naked cells and they produce antibodies against A and against B, you can't give them anything that has an A or B. You'll kill them. So you can't give them A. You can't give them B. You can't give them AB. What's left? O. Right? The only thing they can get is O. Now, what this brings up, look at that. You can give someone with type A O blood. Someone with B gets type O blood. Hey, our AB can have O blood, and O, of course, can have O blood. That makes O the universal donor. Now, blood typing gets much more complicated than this. We do get into dealing with the Rh factor, and that's the plus or the minus, but that one's actually fairly straightforward. So the Rh factor, you either have it or you don't, right? And so this is where you're either plus or minus. This antigen is also being referred to now as the D antigen. So you might see either way, Rh or D. Right? So if you think about this person, if they have that antigen on the surface of their red blood cell, right, this would be Rh positive or D positive. They would not make antibodies against it, right? And so you can give someone who is positive either positive or negative blood, but someone who is Rh negative, wow, right? Since they don't have that protein on the surface, they've never seen it before, right? They might actually make that anti-Rh antibody. Okay, so someone who's a positive blood type can receive either positive or negative. Someone who is Rh negative has to have negative blood. And so then those two really just kind of get put together. If you're B negative blood type, you could get B negative blood or O negative blood, but not B positive or O positive. If you're A positive blood type, you could have A positive or A negative, or O positive or O negative. Right? So that second one is maybe a little bit more straightforward. One of the really fascinating things that happens though with this antigen, do I have this picture? No. So one of the really crazy things that happens, so the ABO blood groups are too big to actually cross the placenta, but the Rh blood group can actually cross. And so what ends up happening is if you have an Rh negative mom, so if she's Rh negative, but the baby, man, why didn't they hire me to draw the pictures in your book, is Rh positive, basically those antigens will cross the placenta and mom will actually start producing antibodies against that Rh factor, right? She's seeing it as a foreign invader, which, I mean, the baby kind of is a parasite of sorts. And so it's not maybe that strange, but mom does start producing antibodies against that Rh positive baby. Usually for the first pregnancy, you get away with it. But then her immune system has been sensitized, right? So it ramps up really easily. So if she has a second Rh positive pregnancy, you can actually develop, it's called hemolytic disease of the newborn, and mom's immune system will really start attacking baby and then get really sick and potentially die from that. So we do have there's a treatment, it's called RhoGAM. Basically, Rh negative mom, before she gets pregnant the first time, needs to be given this treatment. So, okay, blood typing. Look over those other blood tests. We'll talk about them a little bit in lab. All right, I think that's it. Have a great week.